Welcome back. Part 4. I think I finally worked out where I'm going with the editing. Part 4. So, just to recap, got the Arduino Mega, and the reason I'm using a Mega for this is because the original one I'd used a Micro. So there's an Arduino Micro. As you can see, it's much smaller, but it's got quite a limited number of in and outs. And I realised when I started this clock, the time zone Steampunk clock, that even with this number of controls, well, needless to say, you end up needing lots and lots of ins and outs, and the Mega provides, I think, about 54 of them. Sounds like an awful lot. When you start wiring these things up, you realise just how many you're going to need. So I've got that done. I can also, and just a little top tip, can't resist them, sticking a bit of Veroboard onto the surface in the middle of the machine is so useful to create a common ground, common 5 volts, and any other little joins that you need. If we turn it over, I've only got round to fixing the sensor actuators, which is a very posh way of saying these two bits of plastic here. This is the hour hand, like I said before. Stepper motor is going to drive that round, and then it clicks the micro switch. I'm not going to turn this too far because it can damage the little gears inside because it's so highly geared. That means that every time this comes round and the function says, okay, you need to point to 12 now, rather than adding a certain number of steps to move it around like it will for the other numbers, it will say, okay, keep turning until the micro switch switches on. That means it will recalibrate itself every 12 hours. I'm very pleased with that. Now, because the minute hand there is going to go round and round and round, this one can't have something like a micro switch, so I have used, if I can zoom in steadily, there's a reed switch there, and there's a magnet in the end of this. Let's see if, there you go, there's the magnet in the end. So again, as this rotates clockwise, or anti-clockwise if we're facing the back, when this magnet passes over the reed switch, it'll switch it on, and it'll tell the Arduino again, I'm now at that particular position. What that position is, I don't know, it's arbitrary really, but again, I might move the hand so it triggers it once it's at 12 or whatever at the top. Because the reed switch isn't directly on or off at a very predictable point, I'm going to have to set it as I go, get this to turn around slowly until it's within enough proximity to switch it on. And then obviously this means if you use reed switches, you need to have some way of adjusting which direction this magnet is moving, because it's not going to be the same from both directions, if that makes any sense at all. I don't know. So we've got that done, and we've got the very exciting light, the last video with the 6 surface mount LEDs, warm white on there. It's ready to go. Got the lenses and all this stuck together, which is lovely. We've got that from the first video, which I then lost all the encoders. Actually, that's not true. I lost the encoder that I've got, and I ordered 10 more because they're £1 each, which is amazingly cheap considering. There's the switch that's going to be the function switch on the side. Now, originally I had a binary encoded rotary switch. So actually, it had 4 outputs, and it would cycle through the binary numbers up to 16. Now, I haven't got one of those because I've got a load of these, and these are simply on and off. But what it means, having a Mega, the good thing about using this, back a bit, the good thing about using the binary encoded switch was that adding a series of resistors to it means that, and sending the output to the Arduino analog input, it means that you could read what position the switch was simply by reading off and converting an analog voltage created by the combination of resistors. But we're not doing that. Because the Arduino Mega has got so many inputs, I will simply connect 5 wires straight to it. Oh yeah, and I'm just gluing the flute onto the bellows as well, because they're all now dry, and that's silver paint's been drying for days. I'm still being very wary about touching it because it really does like fingerprints. Let's talk about how to turn one of these gate valves into an encoding switch. That means that this can control an Arduino or such like. So there's the top bit, and if you remember the first video, I'd turned down this middle bit so it's 4mm diameter, just under. Here's another encoder, like the one I originally lost. What I've done with this model of them, they're hollow. I don't know about all models, I'm sure it's not the same for all of them. This is hollow, so I can put that in the lathe, drill that out to 4mm as you can see, then slice this additional bit off that had the slot in it. So I'll do that first. Simply because there's not room in this for anything else. Now you can see that pushes onto there. I've cut down these 3 pins because this then sits on a piece of acrylic, 3mm acrylic, and I found the easiest way of doing this is just to poke 3 wires through and solder them onto the top. I'm going to glue that onto the acrylic, and then there's a second piece of acrylic in here that fits inside the funny shaped casting, and that stops the whole thing rotating. I'll get that done. As always, I'm going to put it into position first, and then with the lovely super glue just drip a titchy little bit where I want it to fix down. I'm going to keep it upright because I don't want to risk the glue running into the switch housing. Right, I've got it glued on to those 2 pieces of plastic. I've pushed the wires through with the bared ends, and as you can see, that's by far the easiest way of soldering rather than leaving these pins on the encoder down. I've picked pink because I had a new load of different colour wires and felt a bit of a pink for an encoder. Yeah, I could make these different colours so I could know which one of these connections, but there's so many, it's so complicated. It's far easier just to see, once you've got it all connected up to the Arduino, which way clockwise is and which way anti-clockwise is, and then you can just deal with it accordingly. Now I will put that into here. Oh, and remember that I mentioned it before, if you don't want or haven't got room for this bit, the bottom bit of one of these gate valves, you can just use the top bit and screw it straight into the panel and have some alternative fixing for this underneath. In fact, I wonder whether this would make quite a nice little range of new products. You know, you could have an encoder and a gate valve, you could have one of the indicator, one of these things with a nice lens on with a built-in flickery lamp. That's interesting. Let me know what you think in the comments, dear friends. One last thing before I put it together. I noticed these were very sharp inside, so another great use for the deburring tool. As you will know from previous videos, one of my favourite tools that turns a really unpleasant task into a joy. It's such a clever shape, the cutter, that you could just put it down there, and even from this angle, it will then smooth off any sharp edges. The other thing I'm going to do, which I always do out of principle anyway, is I'm going to use some of this spiral cable wire sort of management system. I'm going to put that over there because, again, just in case any of these plumbing fittings have sharp edges that I've missed, it just gives it a little bit of protection. If it's going to be bouncing around in a truck cab with all the vibrations, I think that's quite important. Okay, stop talking, get on with it. And there we have it, all assembled. And I can feel the clicks as I rotate it. That's really nice. So pleased with this. Yeah, do let me know if you think this might be of interest to people, because I could put all these together and then you could just get hold of this, and you'd obviously have to provide your own Arduino Raspberry Pi or something, but just having this hardware, it's just so nice. Obviously it can be plumbed in as part of a bigger system and actually function, which is, after all, one of my raison d'etres, if you like. Okay, stop talking and get on with it yet again. Let's talk switches. Here's the rotary switch. Very useful switches, these rotary switches. You can get them in different formats where you have a different number of pins in the centre, the maximum being 4, and there's 12 around the outside, so that would be a 4-pole 3-way, 4 separate switches in effect, each with 3 different connections. This one, however, is a 2-pole 6-way, so it's in effect 2 switches, each having the possibility of 6 different positions. All these switches come with this handy little stopper. Now I want 5 positions, so I'm going to turn it back to 1, which is anti-clockwise. Now that one's 2, 3, 4, 5, is it? I can't see. Let's have a look. 1, 2, 3, 4, 5. Yeah, that's it. And then that's held in place once you screw all this together with a lock nut and a nut. Lock washer rather, not a lock nut. That in effect means that you can have this any number of ways. So this I've wired it as one pole, 5-way. So it's 1, 2, 3, 4, 5. There we are. Very, very useful. Now, despite what I said earlier, I've decided to wire it up like this. I had already actually cut 5 separate wires. I thought that's just silly, ridiculous. What I did was to wire it up like this. So one side's going to be 5 volts, the other, we've got a potential divider here. I've decided to use 1k resistors, which means there'll be about 1 milliamp flowing through them all the time, which is not very much. Should be sufficient just to keep a steady voltage across here. That means that when it's here, it'll be 0 volts, and an analog input on the Arduino can then say, okay, if it's 0 volts, do something. That will be, the maths fails me anyway, it'll be a little bit closer to 5, that'll be 2.5 volts, that'll be something, and then that'll be 5 volts. So the Arduino, that means I only have 1 wire, well 3 wires to this switch then. As you can see, I've got the plus 5 volts, the 0 volts at each end of the potential divider, and the one back from the switch. That's 3 wires rather than 5, 6, 7 wires. I've got the switch fitted on now. Fits perfectly in the designated space, and there's even a little cutout for the locating pin to stop it rotating. Although I did find, I've forgotten, these spaces are 10mm high, and this is going to sit on the flat back of the clock face, and all these prongs, all the connectors on the switch were too long, plus the resistor, so I had to squash it all down and trim them off. But that's okay. Now onto the lighting, the illumination. There are the 6 surface mount LEDs glued, soldered on basically to these wires. I've now also soldered on the, what was it, 220 ohm resistor for each of the LEDs. And if you use one bigger resistor or smaller resistor to run several off in parallel, because of slight differences in the way the LEDs function, you don't get a nice even brightness from all of them. You get some bright and some dark, hence separate resistors. Now, because those are going to poke through these holes here, so the next thing is to get all this fixed to the base. I nearly forgot the real-time clock. So this is one I haven't tried before from Adafruit, where everything, the crystal and temperature sensing and everything happens inside this single integrated circuit. Very important because it's going to be living in a truck cab, so the temperature could fluctuate quite a lot, and this will mean it stays absolutely accurate. On the back there's the place for the coin cell to keep it going and remember the time even when the whole unit's powered down. So that's great. The connections for it are plus 5 volts, 0 volts, and then SCL and SDA, which are the data connections, which is great. Again, you don't need tons and tons of wires to be able to communicate the date and time. Just 2, which is fantastic. Apparently these real-time clocks run for 5 or 6 years on one little cell, which is absolutely amazing. Talk about catch-22. I've realised that the best way to put these 4 LEDs in for the time zones is to just push the wires through the holes and leave them hanging until I've fixed this onto this. And I've just screwed down using these 2 screws, and then realised I'd forgotten to put the one in here that's hidden because it would have got in the way with the 6. So I'll take that apart and get that done. But it's very exciting to finally, you can see the AM and PM LEDs, flickering lamps there. That's going to be where the minute hand comes through, and there's where the hour hand comes through. It's very exciting. That looks lovely. Really nice. Not poking through too much, but they just fill the hole, the lenses do, so really nice. And on the back, where are the legs sticking through, and you can see how I fixed them on. In the end, having positioned the legs through the holes, I cut little bits of Veroboard, just with 4 holes in each, couple of strips, and then slit them down, glued them on with super glue, and then soldered them on. And they're now connected up with a common one to the ground. So that's great, and that means the Arduino 4 outputs can be used to switch each one on and off individually. when the fun stops, stop, as the betting adverts say, but I'm having so much fun I'm not going to stop. What I'm going to do now is to get this fitted on, the Illuminations, and then this over the top to hide everything. Now, these two holes have got the spacers underneath, the tapped spacers, so that's great. What I'm going to do, I'm going to use two, oh, here we are, two of the 10mm thick laser cut spacers, but without any threads in. I'm going to glue them on one there and one there. This is now held in place by 2 screws. So having these then glued on means I don't have to worry about it. I can then get long M3 screws like this. It's about 30mm long. So once I've assembled everything else, I can then put that through there. Because if you notice funny shapes here either side with the distinguishing bubbles, the little slots around, mean that this is actually going to glue on to these two. I think, looking at the photos that I've taken of the original one as a reminder, I think they glue on halfway like that, and then that gives enough room underneath. I don't know, I'll have to sort this out before I do too many gluing, but at least having this threaded means if it all goes wrong I can take this off and put things right. Now, remember last time, one of the problems was getting the hands on and off once everything was assembled. So I've glued an M3 screw onto a piece of acrylic which I'm going to glue onto the centre, and then that leaves me an M3 thread to stick up so I can then screw on a lock nut and the hand. How to find the centre of this though, when your reference point is the acrylic hole with a funny shaped slot in it stuck down below the clock face. Well, dear friends, I suddenly had a brainwave. A fabulous use for a pillar drill. So I've got this clamped down, very carefully lining it up with a 1mm drill bit to the centre of the stepper motor. Now I can take the drill bit out and replace it with this and glue it in place. In fact, I'm so thrilled with this idea that I will video it, because this could be very helpful for other people in a similar situation, trying to find the centre of something. There's this bit, so what I'm going to do is put not too much, seems like quite a lot of super glue around there. Then I'm going to, without dropping it into the middle of the dial, put that in there, and then I'm hoping that this, yes, look at that, and then somehow I'll need to loosen that. I thank you, ladies and gentlemen. I think that is classified as a top tip. That could have gone horribly wrong after all this work and then getting it lopsided. I wish I'd done it for this one, but hopefully I've had more room around there so it's easier to see what was going on. Fantastic. I've cut out the hands from the 1.8mm engraving laminate. That's what I'm trying to say. There's a little one, and I'm just using the black side of it. And this is perfect. You can see what I meant by having this thread sticking up, because it means from this side I've got a rigid, well, a stuck shaft, threaded shaft, that I can then use 2 nuts to lock the hand on in exactly the right place, which is fantastic. Because if you remember, the Arduino needs to know where the 2 hands are. The minute hand is going to use a reed switch and a magnet, and the hour hand has got a micro switch that when it points to 12 will click the micro switch. Now I could, I mean I did build in a slot here to adjust the micro switch, and it's such a pain. I remember last time it was such a pain getting it all lined up. Whereas this way, once I program the Arduino, set things up, I can just say, okay, go to 12, and then set this so it points exactly at 12 and tighten it. Perfect. This is the last time we'll see this bit, because, and there's the very small 9BA, I think it is, or something, brass screw. That's going to go through like that. So I'll get this screwed on and then get the little hand on. We'll see what it looks like. It's all coming together beautifully. And there you have it, ladies and gentlemen. I'm very pleased with that. I've put the gem, the lovely sparkly twinkly gem in the middle that covers up the head of that screw. So that means now that I can adjust, if I undo this, take that off, I can get to adjust the hour hand, and I can adjust this simply by adjusting the nut on the front. So that's really good, and I'm really pleased with how it looks. That is very exciting. I'm thrilled to bits, and I have checked all along that all this sits below the level of the glass panel that sits in the recess at the front. It is so exciting because the next step is initially to work out, allocate pins on the Arduino Mega to each of these jobs, so ins and outs, analog ins, the SDA and SCL from the real-time clock, all sorts of stuff. And then to start soldering and connecting all these lovely colourful wires up. And then to start testing the Arduino. It's just so exciting. This is what I love about this sort of project. You've got everything from aesthetics and practical sort of engineering and things, through to electronics and computing, and even to celebrating Victorian engineering and design. It's just fabulous. So, thank you very much for watching. Hopefully I'll see you next time, and remember, as always, I'm happy to answer any questions and respond to suggestions as long as they're polite in the comments. Thanks very much. Hope to see you next time.